I've started the recording. It's about 1:20. So interesting that we have, what, 5 people of the close to 30 in the class. Somebody was saying recently in one of the emails I've been reading, some of the faculty, that they've had really lower than expected Zoom participation as well. So I'm not necessarily surprised, but I'm not heartened by the fact there's only 5 of you, but I'm glad that you're here. So we'll open up the floor for questions. Maybe we could start with any lab related things. We talked a little bit about this on Monday with regard to what I posted in the lecture course shell relating to those exercises 19 through 23. So have you had a chance to start to look at those? Have you looked at the videos? Have you started to go through those Word documents that I have listed the muscles you're responsible for identifying and being somewhat familiar with their actions? Can you hear me?
Yeah.
Any feedback about that? Have you started looking at that stuff yet?
Yeah.
Yeah, I've started looking over most of it. I don't really have any questions though.
Uh-huh.
And yes, I can hear you. So
Okay. I didn't hear anything, so I'm like, I hope you're hearing me. You have your microphones muted for various reasons. That's fine. Okay. How about lecture related stuff? We had, I think, the blood chapter scheduled for this week. And again, I had been working on some voiceover PowerPoints over the break relating to chapter 14, which I think is the blood chapter. Yeah.
I had a question about, I guess not really necessarily a question about content, but I guess kind of further on. So I was watching the one with the bilirubin. I'm probably butchering it, but like the bile with like the gallbladder and whatnot.
Yeah.
So I guess out of curiosity, if you all of a sudden, like I've had my gallbladder removed, what happens when you don't have a gallbladder? And like, do you still produce that? And where does it go? Like, where is it stored instead?
Yeah. The liver still produces the bile. So when you have foods richer in fat concentration is generally when bile is used to help emulsify those fats, which basically means it's like taking a big fat droplet like this. Let's just pretend it's that size, and it breaks it down into a bunch of little bitty fat droplets, which are then acted on by different enzymes in the small intestine. Lipase is one such lipid digesting enzyme. So my guess is, and I don't know this for a fact, but because you don't have your gallbladder, you may have to be more mindful of the types of foods you eat, especially those rich in fats. You tell me if this is true or not.
Yeah.
That you could still eat those, but you may suffer the ill effects by not having adequate amounts of bile emulsifying those fats.
Okay. So since there's not really a place to store it, like someone who doesn't have a gallbladder, there's not really excess. You just get rid of it.
Right. Your liver's still producing it in response to the fat you've got in the food. So I'm just wondering if perhaps the concentration of the bile is less for somebody like yourself versus somebody who has their gallbladder. Have you ever been told, watch what kind of foods you eat?
Oh yeah, absolutely.
Okay.
Absolutely.
Yeah. And so when you do partake in an especially fatty meal, let's say, because you just kind of want to do that, do you pay the after effects in terms of discomfort and all that?
Yeah. Yeah.
Or are you taking supplements at the same time?
No, I don't take any supplements. I mean, my symptoms or after effects aren't as bad as like some other people's. I know there's a lot of other people that have major issues with it, but
Yeah, yeah.
I was just curious if you get rid of the storage aspect, like how your body compensates for it.
Yeah,
But that makes sense.
I can't speak to the medical end of it other than that, you know, the fact that your gallbladder is removed doesn't mean that the liver still doesn't produce bile.
Yeah.
Yeah. You just have
Fair.
nowhere of storing it. Generally, when that fatty food comes into the duodenum, the first segment of the small intestine from the stomach, the gallbladder will sort of contract. It's a little sac, you know, on the
Yeah.
underside of the liver. So it contracts in response to nervous input, and that little contraction is what squeezes that bile down the duct and dumps into the small intestine.
Hmm.
So I don't know if the liver, I don't know how quickly it can kick into fourth gear, if you will, to produce more bile in response to a meal. It
Yeah.
probably can't produce enough like the gallbladder would be able to produce or provide. So you know, I have to do some research and reading on that. But it's an interesting question. So as you started to look at chapter 14, you know, it basically surveys the three types of cells: platelets, red cells, white cells, and goes into a little bit of their differentiation in the red bone marrow. I referenced that figure quite a bit in the textbook there on page 533. So when you look at that sort of flow chart, I'm talking about this one here, right? You don't need to worry about all of these intermediate cell terms or names. You should be familiar with the top cell there, the hematopoietic stem cell, and then as I mentioned, that cell can differentiate into either a lymphoid or a myeloid stem cell. And it's the myeloid stem cell that has the greater potential to eventually form into cells that give rise to red cells, platelets, and 4 of the 5 types of white cells. The lymphoid stem cell, as the first term kind of refers to, lymphoid, lymphocyte, that's what you should think of. That lymphoid stem cell will differentiate ultimately into what are called lymphocytes. That's a type of white cell. So I think I would have some basic understanding, you know, of that flow chart in terms of what I just described. But you do not need to know all of those other intermediary cell types before you get to the formed elements themselves. Note that the red blood cell is anucleate, doesn't have a nucleus. But if you look at the precursor cells that it formed from and trace it, you know, way back up to the hematopoietic stem cell, you notice that a lot of those cells have a nucleus. So in the process of being produced by the bone marrow, those cells, they lose the nucleus, and eventually the red cells produced. And I think that the common thinking is by having a nucleus would take up valuable space within the cell. And does anybody know what that particular pigment is in the red cell that takes up the majority of the cytoplasm?
The hemoglobin?
Right, the hemoglobin, which is of course functioning to transport the oxygen and some carbon dioxide. You would be lessening the efficiency of that cell, at least this is my thinking, if you had a nucleus taking up, I don't know, 25% of the cell cytoplasm. So, and nonetheless, it still lives for, you know, an average of about 4 months before it's recycled by the liver, you know. So that's kind of interesting, I think. Don't need a nucleus to survive, at least red cells don't. Can't live, you know, forever, but 4 months is not bad. And so we go into some detail of those 3 types of formed elements, their counts, how they're produced. There's that figure 14.6 in the book that you should definitely take a look at. It's talking about how in response to low blood oxygen levels. The liver and the kidney respond by producing this hormone called erythropoietin, which encourages the differentiation of the hematopoietic stem cell into myeloid stem cells and ultimately into red cells so that the red blood cell numbers can go up. That's going to help increase the oxygen carrying capacity, right, of the blood.
Mhm.
And as that oxygen carrying capacity rises, it then tells the liver and the kidney, don't produce as much erythropoietin. It's the classic negative feedback that we've talked about again and again, right? All throughout this course. You'll hear about it more next semester if you're taking AP2. So definitely check that figure 14.6 out. It's just classic negative feedback as it relates to RBC production in response to low blood oxygen levels. And then following a discussion of the formed elements, the text talks a little bit about plasma, which is the watery matrix of this connective tissue. Remember, blood is a connective tissue. And then I guess the ending of the chapter pretty much focuses on hemostasis, which is defined as what? Hemostasis.
The stopping the bleeding, right?
Yeah, exactly. That's exactly what it is. Sarah, you got it nail on the head. It's the stopping of bleeding. That's all hemostasis is. And there's three kind of components to it there that I talked about: the vascular spasm, the platelet plug formation, and the blood coagulation, described there on page 545. Yeah. And you should be familiar with the mechanisms, basically, of those three sort of important steps of hemostasis. Blood coagulation is the most complex of the three because it involves a series of clotting factors that have to kind of work one after the other in a particular sequence to form what are referred to as fibrin threads. And those fibrin threads are shown in this photograph here, these yellow threads, which act like a big landing net. I always use the metaphor, because I like to fish, you know. When I'm catching fish on Lake Erie, those big walleyes in the summer, I have a big, long extension landing net that I use to pull the fish out of the water. I don't want to lift it out. I might break the line, right? So the mesh of the landing net helps to contain the fish. Well, in a very weird, dumb analogy sort of way, this landing net contains and carries and contains the what? What does it trap?
Oh, the red blood cells.
Right. Not only the red cells, but
And the platelets and the white cells.
yeah, all of the formed elements get trapped there, don't they? But because RBCs are so much more abundant, you know, in terms of numbers, they're going to be the primary catch, if you will, within the net, right? So a blood clot, I mean, you've all seen one, not to get gross about it, but it's this big gelatinous red thing, right?
Yeah.
It's mostly RBCs. Now, are there platelets in that blood clot? Are there trapped white cells in that blood clot? Sure. But as you know, when we spin blood down and look at the formed elements of that spun down blood sample, right? If you look at the hematocrit here, most of the formed elements are RBCs. You have just a little bit of white cells and platelets in this buffy coat layer. This is a centrifuge blood sample. This is what we would have done in lab had we met. I'm really sorry we can't do that because that's fun.
Yeah, it was really fun last semester.
Yeah, it's real
So
interesting.
is that essentially what they would do if you go to donate, like, your plasma? And
Yeah.
that's why they would, like, I've never done it personally, but they say that there's like 2 IVs and they put the red blood cells back, or no? I don't really know personally.
Well, when you say put the red blood cells back, what do you mean? Back into the person?
So, yeah, I've been told that when you go to donate plasma that you
Oh, yeah.
get an IV in each arm.
Yes, when you donate plasma, correct.
Okay.
Yeah, so somehow, and I can't speak to the technical nature of this process, they're able to separate out the plasma from the formed elements. So you're probably not getting just red cells back, but I would, and I can't speak for sure, but you might also be getting platelets back and white blood cells. I don't know for sure. But they want the plasma for whatever reason.
So that's why it's more extensive, is because the plasma has to be separated out before
Yeah,
anything.
yeah.
It's really weird. You'd think that the red blood cells in that high velocity spinning thing would just crush themselves, or
So that's a good point. We've never taken a look at, like, if you were to break that capillary tube, Sarah, you know, and take a drop, put it on the slide and look, you know, I don't know if you would see any negative impact. You're right, you're spinning that down at a tremendous revolution rate. You know, I can't remember, what is it, 3,000 revolutions a minute, or I maybe more than that even. But yeah, you'd think the cells would somehow be impacted and maybe crushed or something, but I don't know. That's an interesting question. I never thought much about that. Are there intact red cells there? Because you're looking at volume. You know, it's a volumetric analysis that you're doing when you put that capillary tube on that reader. Remember, we used. And these guys don't know what we're talking about, but
yeah.
You rub it in, Sarah. We get to have all the fun in lab.
Well, that particular lab, the blood studies, I'm trying to remember if our lab book even talks much about it. Years ago, before people got all paranoid about using blood and you know, the transmission of bloodborne disease, which I'm not trying to diminish the importance of that, but we used to do so much more hands-on sorts of stuff in lab. And today you go to some schools and you'll use simulated blood for X, Y, and Z test. I think, because I'm old school, that with a little care and precautions, students can still do some of these blood studies safely and get a heck of a lot more out of it than if you use some artificial chemical that you bought from a company to simulate it.
Is it that wouldn't the results be slightly different with the simulated blood versus?
Well, when they go to generate and design these kits, they try to get it such that the results mimic what it would be in you and I.
Oh, okay.
That's all I can really tell you. I don't think you can reproduce the hematocrit. You can reproduce blood typing, you know, with other chemicals, but there's no known substance I can buy other than blood from Carolina Supply Company in down in, I think it's North Carolina, or Ward's up in Rochester. Those are the two big science supply companies. You'd have to buy blood to do that. And typically when we do this, you know, we're pricking our finger and we're maybe using, what do you think, Sarah, maybe 3 drops of blood to fill up a capillary tube. It doesn't take much.
No.
And we're also doing 2 or 3 other tests simultaneously, like blood typing. And then we do a very rudimentary hemoglobin analysis that requires a drop of blood. So you can do 2 or 3 tests with very minimal pain and blood loss.
Why do they take so many vials at the lab when you give blood?
I don't know.
Like when you go for like your first initial prenatal blood work, they take like 8 vials.
Wow.
Oh, it's crazy the amount of blood that they take for that. It's like, oh, I kind of need that, thanks.
Yeah, right. I don't know. You'd have to ask a obstetrician or somebody, I guess.
Imagine. I mean, they're running a lot of tests when you do your prenatals.
Yeah, I was just going to say, if they're doing, you know, tons of testing, I'm sure they're not like asking for more than they probably really need. But 8 vials is, I don't know how many cc's that is, but that's a lot.
I mean, like some of them are little and some are bigger, but it's still, it's like, really? Come on.
Yeah. So if you have questions on any of that, let's talk about that. I'll just say one last thing before I forget, and that is the very last section of chapter 14, which is section 14.5, entitled Blood Groups and Transfusions. I will talk about blood typing when we do this in lab in 2 weeks, but I'm not going to hold you responsible for section 14.5 on the exam coming up. So you can, not worry about that right now, but when we get to that in lab, I'll have you maybe reference back to that section.
While we're talking about it real quick, what all is going to be on the exam? I can't remember what chapters we covered already.
Okay. So we talked briefly about this on Monday, and we said that the exam, which will be, I will have that available on Blackboard on April 24th, which will be, I think that's a Friday. Yep. And I will give some more thought to the time, and I'm trying to remember what we did last time, and there were some students that I know had to work, and I had to adjust a little bit with regard to that time, but it'll be open for a multitude of hours on Friday the 24th, and those exact times will narrow down in the next day or so, and that will cover basically chapters 8, 9, 19, and 14. 8 was the joints of the skeletal system. 9 was muscular system. 19 was respiratory system, and of course 14 was blood.
And you said you'll narrow down the times on Friday, because Friday is the only time or the only day of the week that I work.
And what are your hours?
I work 11 to 7.
Okay, so the morning would be a possibility?
Yeah.
Okay. Does anybody else know whether there's any conflicts with respect to Friday, the 24th, time-wise? Anybody else working at any particular time of day?
No.
We only have, what, 6 people
I
here?
work starting at 1.
Yeah, so if we had it open, say from 9, and I'm just talking off the top of my head here, 9 to 4 or something like that. We certainly could find some time within the day, before or after work, I'm thinking.
Okay.
Yeah.
Okay. Anybody want to offer any more comments on that?
No.
Well, we
I'm
have
free
like
all
I don't-
day, so doesn't really matter to me.
I think that you went over this before, but on the exam, is it actually will we have like an essay portion or no?
There could be certainly essays, yeah.
Okay.
I think I can't do matching. Now, I'm trying to think, did you guys do your third? You did your second exam. Was that in? That was
in
in class, right? So we have not yet had an exam online, have we?
Not for lecture. No.
Okay, not for lecture, yeah. The micro students have already had one online, so I was getting that mixed up with you guys. So the format then for this exam coming up next week, and also for the last exam in lecture, Blackboard does not lend itself to matching, which is typically a part of the format.
Mm-hmm.
So multiple choice obviously works fine. I'm envisioning some multiple choice questions. I'm also envisioning short answer type questions, probably some essays as well. where you're going to be actually able to type your answer like as you would if you were writing it out. And I know it's not the same, but what are you going to do? These next two exams also, I believe, we're upping the points from 80 to 100. Yeah, exam 3 and exam 4 are each worth 100 points. 1 and 2 were worth 80 points. So even though it's, you know, more than a week off, it never it hurts to plan ahead and start going back and looking over, you know, the joints, the muscular system, you know, just maybe do a cursory overview of that, and then go back the next day and put a little more time in. You know what I'm saying? Use your time wisely and gradually build to a point where you're comfortable going into that exam. Cramming is not always a great way to do it, even though I know students do that. It can up the anxiety, the nervousness, all that stuff, and we're trying to minimize that in our COVID life, right? So be smart. Start now. Yeah.
With like the homeostasis with like the blood vessels when there's an injury, how does that work in retrospect?
Hemostasis?
Yeah, sorry.
Okay, be careful.
I know what I could see it in my head, but that's not what I said. In like retrospect to an amputation of, say, like a finger or you know, a leg or whatever, it does, like, when you get the hold on, I'm trying to find it in the book real fast, like the platelet clog and, you know, that kind of thing, does it form like the end of the blood vessel?
In the case of an amputation, you're saying?
Yeah.
Oh gosh, I don't know if they, well, certainly there'd be those events taking place at that damaged blood vessel, but I don't know how they address the issue of bleeding when you're severing some potentially major blood vessels. I have no sense of if they somehow
They'd have to somehow cauterize
them. Yeah, it's, you know, kind of weld them shut, so to speak. But I do not know how that's done. That's an interesting question, because, you know, some of those blood vessels in the leg, the femoral artery, for example, you know, it's big. You know,
right.
Like
I cut off the tip of my finger years ago, and I mean, they didn't end up like cauterizing anything or anything. They just sewed it shut. So I didn't know if, like, when like the platelet plug gets there and it just eventually just like grows together almost, the end of the blood vessel.
Well, whether there are new, you know, angiogenesis, it's called, the formation of new blood vessels. You might remember us talking about that with respect to cancer. Cancer has this unique ability. So whether the body compensates by producing, you know, additional blood vessels beyond that initial site of injury, I don't know. But certainly you had those events take place in your fingertip, you know, all of those things, the spasm, the platelet blood formation, and certainly the coagulation. But it must not have been obviously a major, were you on any blood thinners after that or anything like that?
No, I don't think so.
Yeah, were you just a kid maybe?
No, I was 20 when I did it.
Oh,
So I just didn't know, because I think like with an amputation, like a leg, don't they tie the ends of the arteries off?
Probably. I don't know how you could cauterize them. You probably wouldn't tie them off. And then, you know, like a trunk of a tree, or a tree that if you cut the tree high enough, there's going to be other blood vessels that can sort of compensate to some
Right.
extent. They might have increased blood flow going to them because of the other blood vessel now having a dead end, if you will, to it.
Right.
Yeah, you'd have to do some research on that, I think.
I'm definitely gonna look into that because I
Oh
mean,
yeah, it's an interesting topic. What happens during an amputation? How does the cardiovascular system respond in terms of increased blood vessel manufacture?
That could make a really good extra credit paper.
It sure would. Absolutely it would.
never even thought about that.
No, that's a great question. That'd be really interesting. And I'm sure there's information out there on it. I'm sure there is. Other comments, questions, concerns?
The extrinsic clotting mechanism, that's where the fibrogen net comes in, right? I think it's the
In
net.
both of those.
In both of them.
In
Okay.
both. That's the common thread between extrinsic and intrinsic clotting is once you get down, and I'll just pull this PowerPoint up for you here. Let me share this. Everybody see that on your screen?
Mhm.
Okay. So here's extrinsic on the left, here's intrinsic on the right, and where they eventually come together, which is the lower half of, or lower third, if you will, of this screen, is the formation ultimately of the fibrin clot. So this is obviously the threads that we talked about, the landing net, if you will. So whether it is a clot formed extrinsically or intrinsically, you have to form the landing net. So from this level down, this is common to both mechanisms. The differences lie in everything above here, because if you look at the names of some of these clotting factors, you know, in the case of extrinsic, we've got 3, 7, 10, 5. And on intrinsic, we've got 12, 11, 9, 8. You know, there's your different ones, basically. Yeah. Now, again, some share commonality. So factor 2, factor 2A, prothrombin, you know, fibrinogen, common to both, obviously. And in one of those other earlier slides, if I can find it here, it talks a little bit about, here we go, the fact that the vast majority of these are formed in the liver. Right? So it's a real important organ, not only from a regulation of metabolism point of view, or formation of bilirubin from RBC recycling, but critical organ with regard to clotting. So issues with the liver can manifest themselves in many different ways.
Okay.
And then I did mention in the voiceover, here's a clotting factor number 4. It's not a very fancy long chemical here. It's just Ca++. It's an ion. And we've talked about calcium a lot, haven't we? Whether it's nerve impulse propagation at the neuromuscular junction, whether it's storage in the matrix of bone, whether it's helping in muscle, skeletal muscle, or even smoother cardiac muscle contraction. Boy, you know, calcium is just a really critical element in so many different organ systems. And we've just looked at, you know, 4 or 5 organ systems. We haven't even looked at the other 6. And I'm sure if you did some research, you'd find calcium in there too. So it's really, really important. Other Questions, things you'd like to go over? I think the PowerPoints, I put a lot of time and energy into those over the years, so I hope you're finding them to be helpful. I hope they should be, but you should be looking through the book, reading it, and looking at the PowerPoints at the same time, or obviously watching the voiceovers. But please do get into the book. Don't just rely on the PowerPoint presentations. Get into the book, read it over, look at it.
The lymphocyte, like the T and B lymphocytes. I think the lymphocyte B that is the memory white cell.
Well, both T and B have memory cells, and we'll talk more about those coming up in the last chapter. So Sarah, you're remembering from last semester, yeah, a little bit of lymphatic stuff. I am not going to ask you any of that, at this point in time.
Okay.
I would just be familiar with the fact that we have these two major types of lymphocytes produced once the lymphoid stem cell differentiates in the bone marrow, and then we'll be talking more in that next, well, not the next chapter, but the following one after that, chapter 16. We'll talk about different kinds of T and B cells, of which there are memory T and memory B.
Okay.
Yeah, so more on that a little bit later. And of course, it's kind of interesting that we'll be talking about that system in relation to the coronavirus situation, because you've been hearing on the news now about a lot of studies being done to look at whether somebody who's had the virus and gotten sick and gotten better from it, if we could use some of the antibodies that are produced by these cells, the plasma cells, which are a type of B cell. These are the cells that respond to antigen, and the antigen in that case is the virus. And in response to that, our immune system produces the antibodies, which can basically neutralize the antigen, prevent it from causing more illness. And so you have these antibodies floating around in your bloodstream for a given time frame, and if we can excise that from a patient and then give it to somebody who, let's say, is in early stage COVID-19 or maybe ill with it, we give them those missiles, those antibodies, maybe they'll make a much faster recovery. That's what we're doing massive studies on right now throughout the world, really.
I wonder if
Now,
sorry. Go.
no, go ahead, Sarah. That's fine.
I was just wondering if maybe that would help like people who haven't gotten it yet or haven't gotten sick with it.
Yeah, absolutely. If you had a lot of it, you could give it prophylactically, and therefore, if somebody who received the antibodies, who had never gotten exposed to the virus, suddenly did, that could potentially prevent them from getting sick. You're right. That's a passive immunity sort of thing that we'll again talk about in that chapter. Yes, the answer is yes. Potentially yes.
Now, do you have to, like, is it similar to like you're doing a blood transfusion where you have to make sure that they are, the same blood type, so to speak, or doesn't that make a difference?
I would imagine it would have to be some sort of an IV treatment.
Versus like a vaccine shot like
Right.
kids get.
Right,
Okay.
because in that situation, what you're typically given is a weakened form of the virus. We call it an attenuated form. You don't want to give them the full strength virus because they could then get sick, but you want to give
Right.
them a treated form, which would allow their immune system to think it's the real full strength virus and build up immunity to it, but not necessarily make the person sick. So you're trying to build up protection before the real McCoy is potentially there for you to get. So we get the flu shot before flu season. We should anyway.
Mhm.
right? Theoretically. Now, sometimes you can give it right at it, it just lessens the likelihood of it working because of the time frame being narrower. But, I'm just trying to think now with antibodies. I think in order to have enough antibodies, you'd have to have more than just an injection. But I'm not positive about
I
that.
feel like it might have to be like like they do in the hospitals when you lose too much blood.
Yeah.
Well,
So we were talking about before how with the red blood cells, they only last for 4 months or
Average 4
whatever.
months. Yeah.
So I told you on Monday that my parents both had the coronavirus, et cetera, et cetera.
Yeah.
So the health department is asking my parents to go and donate blood and telling them that they can donate like for the plasma up to a year. So how does that make sense?
Well,
Because your antibody would still just recreate every time that the blood cell recycles?
no. I don't know enough about the viability of the antibodies. Maybe what they're saying is the antibodies survive that long. That seems like a long time. But I don't know. It may depend. I'm not sure how long the viability of antibodies is. I'd have to do some research on that. I don't know. But they're saying a year, huh?
Yeah, well, they said that they can donate plasma every week, which I thought you could only donate typically every month. I mean, granted, I'm getting this information from my mother, so I guess I have to take it with a grain of salt, but that's apparently what they've told her, is that they can donate weekly up to a year.
Weekly.
wow.
That seems awfully frequent.
That's what I
A
thought.
lot.
That's
When
what I
does one
thought.
year blood drawn, do they tell you?
Yeah, regular blood is 56 days. But there's also, ways of returning, like double reds.
Oh, so
So maybe they're really going for these antibodies.
okay, so maybe what they're doing is they're returning the packed cells back to the person, because typically
Yeah.
you would only give blood every 56 days. So they're trying to extract as much as they can from the plasma, right? That would make more sense. So they're returning, I would guess, the packed cells back to your mom.
Yeah, I mean, they haven't done it, but the
Right.
health department is, yeah.
So if you because I was kind of confused as to when you say could give blood every week. That didn't
Yeah.
compute. But if they're giving blood, extracting the plasma, putting the RBCs back in and white cells, I guess they really want that antibody source for
Yeah.
potential use.
But wouldn't that lower the amount of antibodies they have in their bloodstream to fight the virus again?
But if
Right.
they've already gotten over it, does it make a difference? Does that make sense?
Yeah.
Their body would just
Um,
be able to make more, wouldn't it? Because they already know how.
Yeah, but I'm conflicted as to why the body would produce more antibodies once the battle has been won, if you will. During the battle, you're building up antibodies. Okay, when I say battle, I mean sickness. Once you get over the illness, and I don't know the answer to this, how long after the battle has been won do the plasma cells continue to crank out antibody? Apparently, from what I'm gathering here is, even though the battle's won, that doesn't mean that the plasma cells stop secreting antibody. So they must produce it for quite a long extended period of time, which kind of makes sense because you want to really minimize the chance of getting sick from that again. And one way to do that is to keep the antibody level high. Now, I can't imagine the health department would want your mom to give plasma every week and inadvertently knowing that they're jeopardizing her health by making her at increased
Yeah.
risk of getting sick again. That's
wouldn't-
just not going to happen. So it's probably a function of the plasma cells continuing to secrete adequate amounts of antibodies such that you can give us some of yours, and you can still produce enough to be healthy yourself.
Yeah.
That's my guess.
Because that's what I would be worried about, giving up, my antibodies and then not having anybody and contracting it again.
Yeah, and again, I am sure that the health department would not be asking for that in that time frame if that was the case. You'd have to do some more, reading on this. Another good extra credit paper topic. Really interesting paper topic. How long do plasma cells continue to produce antibodies once the patient has gotten over the illness? That I'm sure you could probably find that answer in about 5 minutes after we hang up.
Interesting.
And I'll tell you, in all of the times I've taught microbiology, I have not read anything about that, but it sure seems like it would be an interesting thing to put in a book, textbook.
I'm surprised they don't have that somewhere.
Well, I have my micro book right here, and if you don't mind, I might just take a quick look in the chapter and just see what it says in terms of viability of antibodies. How long? Okay.
Has there actually ever been a a pandemic like today that they would have had the ability to do that? So I guess, is this like the first time that we actually have the medical experience to do it? So that, I guess, I feel like before all this, you never heard about people donating their antibodies, essentially. So
Yeah.
Is it really something people have looked into?
I don't know, like in the case of Ebola, whether they, and that's fairly recent. SARS, which is fairly recent. There's been a few epidemics, not like this, of course, but if you go back and you study this, there have been probably 4 or 5 in the last 30 years where I think they've used antibody therapy, but on what level, I don't know.
Yeah.
Because they were able to contain those epidemics fairly well.
Yeah.
Um,
Well, the other thing is, I guess, the kind of antibody that you create matter how bad you were sick? Because because my brother who's 16 had it, was like not super sick, like kind of like cold-like symptoms, not a big deal.
Mhm.
My mom, the same thing, but my dad, it whooped his butt.
Yeah.
So they're really pushing more for my dad to donate than the other two.
Oh.
But I guess they're kind of taking what they can get on the same token.
Well, it would be interesting to know why they would want your dad's more than your mom or your brother's.
Mm-hmm.
From a microbiology point of view, and immunological point of view.
Yeah.
And those are all interesting questions that if it had been you could have asked the health department, and they would tell you. The reason that they're not telling people that is because most people don't know anything about the biology of this stuff. In fact, if you watch the news, they talk about, well, the virus can live on paper for 24 hours, but can live on plastic for 72. Well, guess what? You've all heard that, haven't you? The virus can live on for X period of time.
Yeah.
Viruses are not alive. They cannot live in the sense of living like you're living. But unless you studied virology, either in micro or later in A&P, I guess we'll talk a little bit about viruses. People don't understand what viruses are. They're acellular. They are not cells. So they don't live like a cell lives. So when I hear people talk, the virus lives on, or the virus lives for, and you hear Anthony Fauci talk about that at the press conferences that the president has. And he knows they're not cellular. He knows they're not alive, but he has to use that language because the average Joe Smith sitting there watching TV doesn't care about that. They want to put it into some conceptual terms that they understand.
Yeah.
Do you know what I'm saying?
Yeah.
So it's just I always kind of laugh when I hear them talking about the virus lives for. Can't live for anything. It's not alive. Yeah, I'm just not finding really anything that talks about duration or viability of antibodies. We will be getting into more of this in lecture in a couple of weeks. And maybe in the meantime, we can find out the answers to those questions, or, you know, your folks could certainly ask the health department too if they wanted to know more about that.
Yeah. It's funny though, because so they let him out of like isolation, and I don't know that they even like follow up with him anymore now. And I mean, it's only been like a week since they've
Oh.
been done with quarantine. So like they're out and about and like not contagious, I guess, anymore.
Right.
But
Well, starting tomorrow, Cuomo is going to institute a executive order whereby every person in New York State, if they come into contact with somebody within 6 feet or less, they've got to wear a face shield.
yeah, my parents are, so they actually own an auto repair shop. So like they're back, but like it was kind of funny. So over the weekend, my parents, they went out to Walmart or whatever, and you know, everybody's wearing masks. And I was like, I'm pretty sure you're supposed to have a mask on. My dad's like, well, I'm like the safest one out here. Like I already had it. Like they don't have to worry about me anymore.
Yeah, but most people don't know that you're like 0.5% of the population who's had it.
Yeah. Yeah.
So even though he thinks he's special, everybody's gonna like think he's the meanest, worst guy in the world.
Yeah. He's like, I'm just going to start telling people, everybody, and they'll know that they're safe around me. And I'm like, what is wrong
Tell
with
somebody
you?
I've had COVID. Yeah, they'll come running and hugging.
Yeah.
You should make him a T-shirt that says it on the front of it.
Yeah, seriously.
Yeah.
Oh, that's funny.
I know my sister-in-law, we just found out yesterday that she's got it, and she's my age, and it's kicking her rear big time. Like she's so short of breath, she can barely speak.
Wow.
And she lives down in New York City, and I said, if it gets any worse, you go to the emergency room. She says, the problem is down here. You go to the emergency room, you're basically signing your life away. And I know I shouldn't do this, but it's taking everything I have to not get in my vehicle and go down there and bring her back here because I know at least up here we've got the beds if she needs them.
Yeah. No, I can understand your dilemma.
It's horrible. And I keep telling her, you'll be fine. You're 37. You'll make it. And she's like, you read all the stories about how people are like, actually very scared for their life while they're in the middle of it, and she is.
Yeah.
It's scary.
Yeah, right. Oh. I just happened to see a headline. Chris Cuomo is the CNN guy that has he's Andrew Cuomo's brother. You know who I'm talking about?
Yeah.
Oh yeah, I've seen his
Mhm.
interview.
And he had some headline like, I'm still running a fever or something like that. I didn't read the article, but it was just, he's still still got it. And it's taking a long time to break the fever for him, apparently.
Yeah, my dad started off with a fever, and then the doctor gave him like that malaria drug,
Uh-huh.
and it broke the fever. But I wonder to a certain degree if the reason that he had such like lengthy symptoms afterwards was because the fever broke. Like if he wouldn't have been better off with the fever in order to kill it, so that he wouldn't have been suffering for so long.
Right.
Yeah.
Interesting question, Juliana. Yeah, you're right. We've talked a little bit about how sometimes we take medications to provide us with short-term relief, but had we let the body, kind of do its own thing, maybe we would have gotten over it quicker. But when you're dealing with this sort of situation, you just can't play around with that.
Yeah, absolutely.
Like my sister-in-law, she's on day 9 and her fever is 103.5, and her doctor just told her to take Tylenol, and it's not touching her fever at all. It goes down to maybe 102 and goes right back up.
Oh, wow. And she's had the fever for how long?
I'm pretty sure 9 days.
Oh my gosh.
Yeah, I told her, I said, if you can handle it staying up, about 100, they let it,
Yeah.
to kill the virus off. And but she's having a hard time.
Has her breathing gotten worse the last week?
When we talked to her last night, she was very labored in breathing,
The worst
and
ever?
that concerned me.
Yeah.
So I mean, and her fiance has it too, but he's nowhere near as bad as she is. And I almost wonder, because my sister-in-law is a vegetarian where her fiance is not. So I wonder if diet kind of plays a role a little bit.
That's hard to say. I kind of doubt it, but I'm no doctor, so I shouldn't offer an
Right.
opinion. People just react differently for lots of different underlying reasons, I guess. Is it possible that her you said fiance, was it?
Yes.
Is just a few days behind her in terms of the progress of the infection, or it is possible that he just like Gianna's brother will have much milder symptoms than
Yeah.
your dad had or your sister-in-law has.
There was also that thing about blood types possibly playing a role. I wonder if that might be part of it.
Melissa, you said that on Monday, I think, too, didn't you?
No, I think Juliana did.
Okay. Yeah.
I just remember
somebody
someone had said it.
I hadn't read that, but that would be very interesting if there was any correlation there.
I might ask them to see if they know what blood type they are and see if they have a different blood type and see if that makes a difference.
It would be interesting to see if there's any data out there that talks about, that. I have not heard much other than what you guys were saying the other day. I think that's interesting. The fact that the hydroxychloroquine, which is an anti-malarial, would be effective against the virus just blows my mind too. What is it about the chloroquine, which is targeting typically a totally different type of cell, which is it's a protozoan, it's a eukaryotic cell. It's so different than a virus, but yet for a lot of patients, some patients, it provides a lot of relief for them. And the studies still are being done, so we don't know exactly, what's going on there, but that's interesting.
I've read a thing too, like zinc and what's the other thing?
Vitamin
Tonic
C.
water. Zinc, vitamin C, and it's in Schweppes tonic water.
I've heard that too with the tonic water. I can't think of the material or whatever you want to call it. It is, but I've heard about the tonic water solution too.
Quinine?
Yeah,
Yeah,
Like,
quinine.
Yeah.
Quinine, yeah. Well, see,
Yeah.
chloroquine has that in it too. So how interesting.
yeah, because I guess they're giving it to the patients down in New Orleans, and within like 18 hours, they're walking out of the hospital feeling 100 times better.
Giving them what?
Quinine and high doses of zinc.
Oh. Uh-huh.
Hmm.
Very interesting.
Well, this is kind of random almost, but yesterday me and my boyfriend had to go in and I had to get horse feed, and we went into Tractor Supply. And while I was there, I looked at like the wormers for the horses, like the worming medications.
Yeah.
And they actually posted a sign. I don't know if they had done it around here or not because I hadn't heard anything, but they actually had a sign posted on top of the wormers saying that the rumors going around about the wormer being able to heal that was not true. And I'm just like,
Oh my God.
who would have thought
I
that?
don't think I would try that.
Well, a couple of weeks ago, after the president was really touting the chloroquine, you heard about the couple that took it because it was used as a aquarium cleaner or something.
Mhm.
Yeah.
Took it
Yeah,
and
and
died.
the guy
They
died.
died.
Yeah. So, people there. I mean, there's people out there that will do all sorts of interesting things. I'll just say interesting, i.e. dumb, because they hear something on Facebook or read something or what have you, and they hear somebody of authority talk about it. And my gosh, you got to be so careful what you say out there, because you could
Yeah.
be causing more injury than benefit.
Yeah. I think that people are kind of just grasping at straws though, because everyone's just so terrified of it.
Yeah, right.
And there's not a lot of information, true information.
Well, you're really right. I think we have to just be always mindful of the fact that we need to let the science take us to where the science takes us, and not be grasping at straws necessarily.
Yeah.
But you're right. In this time of fear and nervousness, and people do things that may not be the best for them.
I mean, we also have to realize that we're talking to like the people who raise the Tide Pod eaters. I mean,
It's true.
Hey, now you're getting pretty close to my generation saying stuff like that.
Well, just make sure you're maintaining 6 feet from each other, and drink a lot of tonic water, and get some dewormer, and you'll be fine.
As of tomorrow, we're supposed to be wearing masks to go out. Is that what?
Well, he said on his news conference today that he's going to issue an executive order, I'm assuming today or tomorrow, that all New York residents, if they come into 6 feet proximity while in public, need to wear a face mask.
Huh. Well, you're not gonna be able to find them anyway, because I'm sure they're sold out everywhere.
Well, you can make your own.
Yeah,
there's
people
not-
have been making their own.
yeah,
Where-
it doesn't have to be a medical grade one.
Where I work, we had to have them like certified or whatever, I guess. But they're still homemade ones. We had, like last week, we had to start wearing them.
Oh.
I'm gonna have to switch to my contacts because every time I wear mine, my glasses fog up.
Nope.
That's what I do
Oh.
too.
Uh-huh. Yeah.
My whole
Sure.
family has some homemade ones, and we've seen a good way to test it to make sure it's like actually working is to stand in front of a window or a mirror or something and just breathe. And if you fog up the glass, then it put like a coffee filter or something in it, or it's not thick enough.
Oh.
Yeah, a lot of people were saying coffee for the homemade ones.
Mm-hmm.
Yeah, and a lot of the patterns have like a place for you to slip a coffee filter in. That's how my families are.
Mm-hmm. Mine too.
So there goes the coffee filter. It's just like the toilet paper.
Yeah, stock up on coffee filters with your toilet paper, and if you run out of one, you can use the other.
You mean wipe your butt with a coffee filter?
Don't
I mean,
flush it.
there's not
Don't flush
too
it.
May come to that.
Desperate times call for desperate measures, you know?
That's right.
I guess
Well,
it's
I'm
better
glad you are all healthy and you came to the meeting today. And if we learn nothing about blood, we at least have talked about COVID-19, and that's not bad either.
It's a win in my book.
All right.
And
Well,
who
listen. Any other questions about chapter 19 or not 19, 14 is it?
I don't think so.
Otherwise, our next meeting is scheduled for Monday, and I'll send an email out, I think, to everybody, just kind of reiterating the fact that we've got the test coming up next week,
Right.
No, we have a quiz in the lab on Monday, right?
and we have a quiz on Monday in lab. Yep, and I told you guys about that it was going to be open from noon to 5. Yep. So yes, thank you for that reminder. All right, anything else?
Just one more quick question. For diapodesis, diapodesis,
Yeah.
is it just the leukocytes that can do that, or all of them?
No, it's leukocytes. There'd be no reason for red cells or platelets to leave the bloodstream.
Okay.
And I'm trying to find that slide. It's somewhere here. I know where it is. Yeah. Yeah, white cells.
Okay.
Okay, I will see you guys on Monday.
Sounds good. Have a good
Alright.
weekend.
Okay, you guys too. Thanks for
Stay safe,
stopping.
everybody.
Yeah, stay safe. Thanks.
Bye.
Bye.